This is the last practice problem that I have been given, but I want to share this one with you. And I'm guessing that this will not be a short video. I'm hoping that there's an easier way to do this problem, but this is the way I've come up with to do it today. But consider the graph of the function below. Then it says, determine which sequences of transformations could be applied to the parent function f of x equals x to obtain the graph of g. So we want to get back to this picture that's given on our graph. So I'm going to switch over to graph paper momentarily, but the first thing that I want to point out is that the y-intercept of this graph is 6. And then our slope is, well, we can go down 6 to the right 2, or we can go down 3 to the right 1, which I have written both of those down over here on my graphing paper. And hopefully you can pull this problem up on your screen at some point if you come up with it and you need it. But the first choice here says that we want to reflect over the x-axis. I can show it to you still. Reflect over the x-axis, vertically stretch by a factor of 3, and then shift up 6 units. So I got out my colored pencils to do this, and so when we start here, I'm going to start with blue, and we're going to reflect over the x-axis. Eventually, notice that I've got the slope and the y-intercept up here. This line that I have drawn is f of x equals x, which, by the way, is the same thing as y equals x. And what you can see on mine that you can't necessarily see on Desmos or on the computer program is you can see some points on there. But f of x equals x has slope of 1, rise 1, run 1, up 1 over 1, up 1 over 1, and the y-intercept is 0. But again, the first statement in this program says it reflects over the x-axis. So if it reflects over the x-axis, the point on 0, 0 is going to remain the same. But this point here, here's our x-axis. It's 1 above the x-axis, so there's going to be 1 below. This point here is 2 above the x-axis, so if it flips over, it's going to be 2 below. And it's the same thing on the other side. This is 1 below the x-axis, it'll become 1 above. This point is 2 below the x-axis, 1, 2, so 1, 2 on the other side. So there is the reflect over the x-axis. The next part here is we're going to vertically stretch by a factor of 3. So luckily on this one, I have 0, 0 on here. You want to maintain the pattern on this blue line, even though I didn't connect the dots, and I'm not going to. But instead of going down 1 to the right 1, down 1 to the right 1, we're going to go down 3 to the right 1, down 3 to the right 1. The 0, 0 stays the same, or we can go up 3 to the left 1, up 3 to the left 1. So there is the vertical stretch by a factor of 3. And then lastly, we want to shift up 6 units. So I'll switch over to green and switch. So that means that the y-intercept point is going to go 1, 2, 3, 4, 5, 6. And I don't have very much space, but if I go to this red point here, 1, 2, 3, 4, 5, 6. In the very bottom red point, 1, 2, 3, 4, 5, 6. You'll notice if you look at here, the y-intercept is 6, and then the slope is down 6 to the right 2, or down 3 to the right 1. So our first choice there is reflect over the x-axis. When we look at the second choice, it says sorry about the lights. It says shift right 6. Well, where we went on this graph is we went right 2, so it's not that one. The third one says shift left 2. So again, we went right 2. So it's not going to be that answer either. So let's jump down to the fourth one. So I have a new graph, and I know, but there's got to be a more efficient way. But I hope that this is visually showing you what's happening. And it starts by shift right 2 units. So we're going to take this graph and we're going to shift right 2 units. 1, 2. 1, 2. I'm counting right 2. 1, 2. 1, 2. So there's the shift right. Again, I'm on option 4 on here, shift right 2 units. We're going to reflect over the x-axis now. So if we reflect over the x-axis, so this point here, because this is the x-axis, it's 2 below the x-axis, it's going to become 2 above. This point is 1 below the x-axis, it's going to become 1 above. This point's going to stay the same. This point here is 1 above, it's going to go 1 below. This point is 2 above, going to go 2 below. So there is the reflect over the x-axis, and then we're going to stretch vertically by a factor of 3. Now we have to be really careful on this because I had to start at 0 when I stretched by a factor of 3. So I'm starting at 0 to do that, and you need to maintain the pattern of the line, which is a negative, but we went up 1 and to the left 1. So instead of going up 1 and to the left 1, we're going to go up 1, 2, 3 into the left 1. And I don't know why I started there, but because I should have started here. Up 3. No, I'm going to stick with what I did. Up 3 into the left 1, starting at the 0. Up 3 into the left 1. We did this point, up 3 into the left 1, so I can go 1, 2, 3. Boy, I'm messing up on this, but yeah, I think I'm okay. Up 3 into the left 1, up 3 into the left 1. This one would remain as is, and if you notice, here's our y-intercept of 6, down 3 to the right 1, down 3 to the right 1, or down 6 to the right 2. So it is going to be that choice as well. If we look at option number 5 here, reflect over the y-axis. So I still have this line y equals x, f of x equals x. If we reflect over the y-axis is this one. 0, 0 is going to remain, but now this point is going to go here. It's 1 space away from y. This one is 2 spaces away from y, so 2 spaces away from y. 3 spaces away from y on the other side. 3 spaces away from y. And it seems like I missed that point, and I did. But 3 spaces away from y. Same thing. 1 space away from y, 1 space away. 2 spaces, 2 spaces. So there we get that one. So there's the first transformation that's listing there. Now it says vertical stretch by a factor of 3. But once again, the nice part is that we still do have this. And you want to maintain the pattern of the line, so instead of down 1 to the right 1, we're going to go down 3 to the right 1. Down 3 to the right 1. Or you can go up 3 to the left 1, up 3 to the left 1. So there's the second part, the vertical stretch. And if you notice, all of them have vertical stretch. All the choices have vertical stretch by factor of 3, so we know that's that. And then lastly, we're going to shift up 6. So if I start with 0, 0, 1, 2, 3, 4, 5, 6, but remember that red line, it has down 3 to the right 1, down 3 to the right 1, down 3 to the right 1, and what we can see is we have our y-intercept of 6, we have our x-intercept of 2, we have the correct slope, so it is this option, reflect over the y-axis, vertical stretch. And I'll let you try the last one. I do think that it does not work, but give it a try. You've seen 3 examples of me working these out. It's always good to try one on your own, and feel free to set up a virtual meeting, especially if you want to go over this problem some more.